Okay, the key thing about this question is that we need to set up the volume of this in terms of this length x. We can begin by setting up this volume, which is 1 over 3 pi r square h, but both h and r needs to be represented in terms of x. H and r has a relationship, right? H squared plus r squared is equal to, this radius is 4. So it's going to be 4 squared. Okay. So that will allow us to, for example, change h in terms of r. Okay, so what is the relationship between r and x? Well, this length here is equal to this length. So 2 pi r is equal to, right, the circumference of this, which is 2 pi 4 minus x. Okay, so that creates a relationship between r and x. Right, so r is 8 pi minus x over 2 pi. Or that's 4 minus x over 2 pi. Okay, but if you plug that in here, right, r is 4 minus x over 2 pi. Okay, now we can represent h in terms of x as well. So h is going to be square root of, this is 16 minus 16. If you multiply this, you get minus 4x over pi. And then you also get, so that's minus, it becomes plus. And the last term becomes x squared over 4 pi squared. It's nice, that cancels out. So 4x plus x squared over, I guess we can factor out, well, let's just leave it. Okay, we can definitely simplify that. But you get the idea. Oops, I said let's leave it and I'm trying to combine it in an illegal way. Right? Yeah, the common base will be 4 pi squared. You have to multiply here by 4, so you get 16 pi x plus x squared. So the denominator becomes 2 pi. Alright, so replace h with this, r with this, and now we have a v as a function of x. Okay, so let's write this out. 1 over 3 pi, 4 minus x over 2 pi squared, and this. Okay, so that cancels out. That gives you 1 over 6. Okay, so now we need to differentiate this. But let's just clean this up. 1 over 6. This is actually 8 pi minus x squared over 2 pi squared, so that's 4 pi squared. Okay, just gonna pull that out, so it's 24 pi squared, and you're left with 8 pi minus x squared, 16 pi x plus x squared. I don't want fraction if I don't need to in my differentiation, right? It's gonna complicate my expression for my derivative. So now let's differentiate. Okay, this is not going to be involved, right? So we get 2, 8 pi minus x. Differentiate that, you get minus 1. Plus. Differentiate that, we get this. And then chain it, and you get 16 pi plus 2x. Okay, so if you actually, let's see here, we can reduce this to get 8 and 1 there. 8 and 1. Okay, let's create a common base of 16 pi x plus x squared. So this becomes now minus 2, 8 pi minus x. This times by this is 16 pi x plus x squared. And you have 8 pi minus x squared, 8 pi plus x. Okay. Okay, so we can actually factor out 8 pi minus x. So 8 pi minus x, let's factor that out. Okay, and let's expand the minus 2. And we need to expand 8 pi minus x with 8 pi plus x, which is 64 pi squared minus x squared. Same thing at the bottom. So that's minus 3x squared. And so minus 3x squared minus 32 pi x plus 64 pi squared. That's a constant x term, x squared term. Okay, so this will equal to 0 when that's equal to 0 and when that's equal to 0. So when x is equal to 8 pi, or, okay, you can use this quadratic formula here. So b minus b, which is 32 pi squared minus 4 ac. All over 2a. Okay, let me punch this in the calculator. Maybe I can simplify this without a calculator. So 32 times by 32 is like 32 pi squared is 32 times pi squared. So if you borrow 2 from here, you get 16 times 64 times pi squared. So you can definitely factor out 64 pi squared from inside the bracket, and you're left with a 16 plus 12. So 32 pi plus minus, this is going to be 8 pi, and this is 28. Divide the top and bottom by 2, you get 16 pi plus minus 4 pi root 28. Okay, so that doesn't really help. I think we do need this in a decimal value to make a sense of it. So we reject the negative answer. So it's 2.7. It's 2.7 or 8 pi. Okay, but let's go up here. Do you see how 8 pi is actually the whole thing, right? So that's basically we have no cone. We cut up the whole cone, right? So it's actually this. That's the x value that we want, which will maximize the volume of the cone. Okay. Or in the exact value, it's the okay, or reduce top and bottom by 2. This is 4 times 8, so actually you can do 2 times by 7, so you get 4 pi here, like that. Okay, that's the exact value. You can even factor out 4 pi to get 2 minus root 7 all over negative 3. I guess 4 pi root 7 minus 2 over 3. That's the cleanest look. You can make it look as an exact value.